Hey guys, so I'm going to be walking you through the Algebra 1B practice semester exam. And the idea with me working them out with you is so that you'll be able to keep this right next to you when you're taking your exam. And you can refer back to it to see how we worked each one of these problems so that it can help you with the ones on your exam. Now, we're going to get started with number 25. I like to keep an extra piece of paper right by me when I'm working these because I take up a lot of space when I work. So I'm just going to keep this paper here, and we're going to work number 25 on it. So, at Penny's Diner, 2 eggs with bacon cost $3.25. 1 egg with bacon costs $2.25. At these rates, how much would bacon alone cost? Now, what we're going to do is we're going to set up 2 equations, and we're going to solve for bacon. So now there's a trick because you could spend a whole lot of time finding both eggs and bacon, but they're only asking for bacon. So we're going to give eggs a variable and we're going to give it E, and then bacon we'll give B. So we'll be solving for B. 2 eggs with bacon cost $3.15. So that's going to be 2E plus B equals 3.15. 1 egg with bacon costs $2.45. So E plus B equals 2.20. Those are our 2 equations. Now we're going to find B. So we're going to subtract E from both sides on this one because we can easily get B by itself. So minus E. Now we're going to get B equals 2.20 minus E. Now, how this is going to work is we're going to substitute B into this equation. So 2E plus 2.20 minus E equals 3.15. Now, collect like terms. So 2E minus E is going to equal just E, plus 2.20 equals 3.15. Now, we're going to subtract 2.20 from both sides. And that will give us E equals, you can easily subtract there. We're going to get 5 to 9. So we're going to get 0.95, so 95 cents. Now, we're going to substitute this back into this equation here. So B equals 2.20 minus 0.95. Now, that is going to give us, we can put this in a calculator or you can subtract it on your own, but 2.20 minus 0.95 will equal 1.25. So bacon equals $1.25. There you go. Yeah, bacon. Now, we're going to move on to number 26. So, how we're going to solve number 26 is we're going to divide 12x to the third minus x squared plus 4. We're going to divide that by 3x plus 2. So set it up like you would a normal division problem. So what we're going to do is, I like to call it a house. So we're going to put 3x plus 2 on the outside of the house. 12x to the third minus x squared. Now, we have to have a placeholder since this does not have a single x value. So we're just going to put plus 0x because we have to have that placeholder there. Now, plus 4. So we're going to ask ourselves, what times 3x will give us 12x to the third? So that's going to be 4x squared. Put that there. Now multiply that. So 12x to the third. 4x squared plus times 2, is going to equal 8x squared. So plus 8x squared. Now, plus, but you could subtract. But it's so much easier to add a negative value. So what we're going to do is we're going to change the signs on all of them to negative. Change the signs. So that's obviously going to equal 0. And then a negative x squared plus negative 8x squared equals negative 9x squared. Then we're going to move this 0 down. So we're going to ask ourselves again, what times 3x will give us negative 9x squared? And that's going to equal negative 3x. So we're going to put negative 3x. Multiply, again, negative 3x times 3x equals negative 9x squared. Then negative 3x times 2 equals negative 6x. Once again, change the sign. So change the sign and change the sign. So that's going to cancel out right there. And then 0x plus 6x equals 6x. Move the 4 back down, plus 4. 6x. So 3x times 2 will give us 6x. So plus 2, which equals 6x. 2 times 2 plus 4. Once again, plus, change the sign, cancel out, we're going to get 0. So the simplified form of this, simpler form, is going to be 3x plus 2 and 4x squared minus 3x plus 2. So that would be our simpler form. Okay. Moving on to number 27. So how we're going to solve this system of equations is we're going to get y by itself over here. So actually, the easier way to do this would be get x by itself. So x equals, and then we're going to solve that. So we're going to get x by itself. So x, and we're going to subtract 5y from both sides. So x equals, so minus 5y, 4 minus 5y. Now, how we can do this is we're going to substitute x into this other equation. So 4 minus 5y and parentheses, so we can distribute, minus 7y equals negative 10. So distribute, 3 times 4, 12. 3 times negative 5y is negative 15y. Minus 7y equals negative 10. Now collect like terms. Negative 15y minus 7y is equal to negative 22y plus 12 equals negative 10. Now, we can subtract 12 from both sides. Negative 22y equals negative 22. So divide by negative 22 on both sides, which obviously is going to give us y equals 1. Y equals 1. So we found one variable. Now all we have to do is plug y equals 1 back into this equation that we found earlier. So x equals 4 minus 5, and y equals 1, so 1. X equals 4 minus, so x equals negative 1. So we're going to put this in a coordinate form. So x is negative 1, y is 1. And that is your solution to this system of equations. Now, we're going to move on to 28. So it's asking what type of function is in the chart below. So we're going to work on number 28 here. And so if you'll notice, every time you go to a different x value, the y value is multiplied by 4. So 4 times 4 is 16. 16 times 4 is 64. And since it is multiplication between the y values, this would be an exponential function. Exponential. Now, if it were adding, then it would be linear. So this type is an exponential function. Now, we're going to move on to number 29 here. It says, what is the degree of the monomial? Sorry. So it's 6x to the 5th. Now, super simple. This power right here is the degree. So all you have to do is look at the degree, and this is pi. So the degree of this is 5. Super easy, right? Now, number 30. What is the factored form of the expression? So h squared minus 64. Now, if you'll notice, there's no single x value here. So when that happens, we look and we see if the constant is able to be, you take the root of it. So the square root of 64 is 8. And since it's a negative, what we can do is, so factoring here. Now, if you're to take square root of h, it's h. So h. Now, no x value. So if we were to factor this out, we would get, you would find that you would get negative 8 and 8 in each one of these, because negative 8 and 8, if we were to distribute, it would cancel out each other, and we would get negative 64 instead. So negative 8 plus 8. Now, if you wanted to check it, you could distribute it out. Both negative 8h and 8h would cancel each other out, and you would get h squared minus 64. So this is the factored form of h squared minus 64. Now,
hey there, I want to take a quick minute to solve this quadratic here by completing the square for number 31 on your semester exam review. So let's do a quick reminder. When we complete the square, we want to create space on each side of the equation, and we're creating that space because we want to fill it with a number. Now, to determine what that number is, we're going to take the negative 6 here, we'll cut it in half, and we'll divide, and then we'll square it. So negative 6 divided by 2 would give me negative 3, and then we square it to give me 9. That tells me what number should go in each of the blanks. I want you to notice that each blank got the same number. That's important. Now, after we fill the blank, then we take the left side and we factor that. We know that that would give us x minus 3 squared. And 16 plus 9 would give me 25. Now, once I've factored it, then I want to take the square root of both sides. You may be asking yourself, well, why do I want to do that? And the reason is because when we take the square root of the square, those two are going away. We're going to be left with just x minus 3. I hope you noticed that over here on the right side, I used the positive negative because I do need to have two solutions here. And we know the square root of 25 is 5. Now, let's split these into two solutions. So I get x minus 3 equals positive 5, and x minus 3 equals negative 5. These two become pretty simple equations that I can then solve. So I got x equals 8. And over here I got x equals negative 2. So I hope that helps you with your completing the square.
now we have one more here on this page, number 32. And it says, what is the length of the hypotenuse of the right triangle shown below? Now, I hope you're thinking of the Pythagorean theorem, which is a squared plus b squared equals c squared. Now, c squared is c actually is the hypotenuse, so we'll be solving for c here. And we have the two other legs, which is 24 squared. We're going to put that in for A, and we're going to put 16 in for B. Now, we're going to use a calculator. You can either use Desmos or a TI-84. I'm going to be using a TI-84 for this. So 24 squared plus 16 squared equals 832. So c squared equals 832. Now, we can square root that using our calculator. So we're going to take the root of 832, press enter, and it's going to give us 28.84. And that is our hypotenuse. Now, that is the last problem on this page. There are more pages in the practice. So if you would like to watch the other videos, I will leave them linked down below. Just make sure you click on them, and I will work through the other problems with you. Thanks, friends.